I'm actually really glad we went over the solving linear equations again. I think seeing it second time and working through it really helped. I felt like there was a confidence level that was built. So that's good. Okay. All right. Hi, Lynette, how are you? Just connecting. Okay, so what we're going to do today is we are going to continue with graphing linear equations. And we're going to, we started the graphing slope of a line using the intercept method. So let me share my screen and open up our OneNote. And so just kind of a reminder, I call the intercept method the cover-up method. And hang on. Where am I? Hang on 1 second. All this technology stuff. Oh, that's fine. I'm not showing my face. There we go. Okay. All right. So with the cover-up method, remember you're finding to get any line, you have to get 2 points. So any 2 points on the line. So in this case, what we're doing is we're finding the intercepts where it crosses the y-axis and where it crosses the x-axis. So those are called the x-intercept, y-intercept. And so those 2 points you'll be able to create any line. So with this one, with the cover-up method, the green shows I'm covering up the y term. And when you cover it up, what's left is the x term. And so you're looking for the x-intercept. And the reason why that 2y goes away is because you're replacing the y with 0. So this becomes 2 times 0, which is 0. So that's why I just cover it up, because it goes away. And then I can solve 5x equals 10, divide both sides by 5. I'm looking right here. And I get 2. So my x-intercept is 2. And remember, your ordered pairs are always in the form y, x and y. X is first, y is second. And then to get the other one, we cover up the x term. And then I have 2y equals 10. 10 divided by 2 is 5. And so again, this right here tells me which intercept I'm looking at. So you have the answer sitting right in front of you. It's just, are you recognizing it? So once you get those 2 points, you plot them, you connect the dots, and you're good to go. Okay, so just a quick review. All right, so now let's jump in. So we have, you have all the tools you need to graph this. And what I'm going to do is, because the minute I see fractions, I go, I don't want to deal with fractions. So remember that whole idea of eliminating the fraction. Okay, so what's your common denominator going to be? Good. Right, now, again, if you don't see it right away, it's okay. You'll get better at it. What I do is I take my biggest number, it's 8, and I go, okay, 4 can go into 8 and 2 can go into 8. So that's a great idea. If you don't see it, just multiply them. 4 times 8 is 32. See if 2 goes into 32. Or you can go 4 times 8 times 2. It really doesn't have to be the lowest common denominator. It just has to be a common denominator. Okay, all right, so here's our technique. 4 goes into 8 twice. And remember, you're getting rid of that fraction. 8 goes into 8 once, and you're getting rid of the fraction. 2 goes into 8 4 times, and you get rid of the fraction. Okay. Oh, sorry, Nathan. This is page, what are we on? We are on page, what is it? 74. Thank you. 74. Okay, so that's one technique. You divide, and then we're going to multiply. So we end up with 2y. So 2 times 1, so we have 2y minus 1 times 1 is 1, so minus x equals 4 times 1 is 4. So remember, that's one technique. The other technique I'm going to do it in a different color. The other technique is I multiply 8 through the top and then I reduce. So 8 over 4y minus 8 over 8x equals 8 over 2. And then you reduce. So remember, this one in the yellow, that is reducing first and then multiplying. The one in the purple is multiplying and then reducing. But you see, you get the exact same function. They both work. So you just pick which one you like. I'll try to do both, or I'll try to do, you know, flip back and forth, just so you see it both ways. But again, it's completely up to you how you want to do it. Okay, now we can do our cover-up method. So this one, I'm covering up my y value, which means my y value is 0, and I'm solving for x. So I have negative x equals 4. Divide both sides by negative 1. So I get x equals negative 4. Okay, so this is my point. So remember, you always want to write it in ordered pair, in an ordered pair, because this is a point. So we come over here and we put a point, oops, sorry, wrong spot, on the x-axis at negative 4. And what I just did is a super common error. So sometimes, especially as you're learning, put a y above the vertical line and an x along the horizontal line, and that will just kind of give you a reminder of where the point goes, because we were looking for our x-intercept. Okay, and then I'm going to come over here so you can see I can use either one. I cover up the x, and I end up with 2y equals 4. So divide both sides by 2, and I get y equals 2. So the point, x is 0, y is 2. So I put a point right here. And there is your line. That's it. All right, any questions? I don't want to go too fast, but I know we need to finish because you guys have a test next week. Do you realize that? It just hit me last night. I was wide awake going, oh my gosh, I got to get a review. So Monday, what we'll do is we'll go review for your test. And then Wednesday will be your first test. Okay. All right. We're going to skip 11. I want to leave some for you to practice on. So let's look at number 12. This is on page 75 in your packet. Okay, so go ahead and try that one. Cover up, and it doesn't matter which one you cover up first. Just pick a term, cover it up, solve for the other value. And then for those of you on Zoom, give me your answers in chat. You can just write it as your ordered pairs. Robert, do you want this document and what we're working on? It's just a map packet. Yeah. Okay. All right. Okay. So we're covering, I'll just cover up the y first. So what do you get for your x term or your x intercept? Good, -3. Good. Okay, so I have negative 2x equals 6, divide both sides by -2, and I get x equals -3. Everyone good? Okay, and then I'm going to come over here and I'm going to cover up the x term. So that means x is 0. And what'd you get for the y term this time? I got 1/2. Okay, are you confident with that? Trust the math. Honestly, trust the math. As soon as you set it up, it doesn't matter if you have done the algebra correctly, you divide both sides by 12 and you get 6/12 or 1/2. So never question yourself or, second guess yourself if you know you've done the math right. All right, so here's our 2 points. So x, come over here, -3. Y is 1/2. So here's 1. So I'm just going to put a point right in between. And then here is our line. And you're going to pretend that's straight. Okay. All right. So, okay, so now let's look at something. So if you notice on 13 and 14, 13 only has a y, 14 only has an x. Okay, so what that means is when you have y equals some value, this is going to be, if I set this up in a t-chart, right, just graphing, here's my x, here's my y, and y is the only value that I have, then it doesn't matter what x is. So let's first find out what y is. So you're just going to solve for y. So what's the process? How do I do this? What do I got to do? By what? Okay. All right. You can do that. So we can do it that way. So if we multiply both sides by 2, we get 2 goes into 2 ones, and then 2 times 10. So it's going to be 5y equals 20. That's one way to do it. Does anyone have a different way to do it? How do you get rid of multiplication? Division, right? So if I'm dividing by a fraction, right? I'm dividing by 5/2. All that means is I'm going to flip that over and multiply. So remember, if you had 5/2 divided by 5/2, that's the same as 5/2 times 2/5. And you can see this cross cancels to 1, and that's what we want. Okay. So then I get y equals, and this is 10/1, so I can cross cancel, and y equals 4. Now, if I did it up here, divide both sides by 5, I still get y is 4. So either way works. It just depends on how your brain kind of works through everything. Okay, so either way works. All right, so here's what this means. If x is 0, y is 4. If x is 1, y is 4. Because what this is saying is y is 4 every single time. If x is -1, y is 4. If x is 100, y is going to be 4. All right, so if you graph that, when x is 0, y is 4. When x is 1, y is 4. When x is -1, y is 4. When x is 10, y is 4. -10, y is 4. So do you see what kind of line you get? You get a horizontal line. So anytime you have y equals a value, you're going to end up with a horizontal line. Okay. So if you notice in the other equations that we did, we had an x and a y. That's how you know it's going to be a linear equation. It's going to be, oblique. There's going to be some kind of a slope or a steepness to it. When you only have one variable, either x or y, it's still a line. It just is going to go in a different, it's going to be a specialized line, if you will. Okay. And then same thing for 14. So 14, notice. So it's the little details in math that you have to really pay attention to. So if you notice, there's only an x. It's like, okay, I can solve for x. I'm going to divide both sides by 8. And I get x equals -2. So same idea. If x is -2, y can be anything. Doesn't matter. X is always going to be -2. And I always go, a 0, a positive value, and a negative value, just so I have it on both sides of the line. So here we go. -2, 0. -2, 1. -2, -1. I could have -2, 10, or -2, -10. But what you end up with, that's straight. So hard. Yeah. Oh, you have one of those like Robert.
It just looks like fabric.
Just bigger. Oh, okay. Yeah, this one. Oh, I know. All right. So this is when you have x equals a value. We have a vertical line. Okay, so those are two very special lines. The horizontal is when you have y equals some value, and the vertical is when you have x equals some value. Okay, so here's how I would do this. If you had an equation, I'm going to do it on this little graph. If you had an equation, x equals 3. Here's the easiest way to do this. You really don't need this chart. This was just so you could see why you end up with a vertical line. So now that you know that, you go, okay, there's just the x. X is going to be 3 no matter what. What you're going to do is you're going to come over to x is 3, put a point, and put a vertical line through it. And then you can check, okay, when x is 3, y is 2, x is 3, y is -4, and so on. It's a vertical line. If you have y equals, say, I don't know, -8, you're going to come down to the y. You're going to put a point on the y at -8, and you're going to put a horizontal line through it. Okay, and then you can double check. When x is 1, y is -8. When x is -4, y is -8. So you can see that you have the line in the right spot. Okay, so any questions on horizontal or vertical lines? This is horizontal. And how you remember horizontal is the horizon. When you look out on the horizon, you see out flat, right? Vertical, I don't know. I don't have a trick for vertical. Vertical is the x. Let me see if there's anything else I need. Then there's your homework. So we got homework on that. Okay. So now, no questions. Yes? No? Need to see anything one more time? All right. So before we get to the slope-intercept form, on the table there is I don't know what this is called, a document that looks like this. Okay. And there's two different ones. One has a point on there. It says 2, -4, 1, and 3 down in the slope corner. And the other one has in the circle, it has intercept method on one side and slope intercept method on the other. So turn it to the side that says the intercept method. So what I like to do is I like to give you one document that you can use for your test. This has all the information you need to be able to remember, okay, what does it mean to have the intercept method? So this I'm going to do as the intercept method. You need another one? I have more. And remember, I call this the cover-up, because you're covering up one term, covering up the other. You'll need both of them, so got them. All right. Okay, so for those of you on Zoom, this document is in the class in the module, so you can pull that up if you want, and you can. I will post this so that you have an example of it, so you can fill one in. All right, so here we go. I am going to give you an equation. The equation is 2x, so put this in the circle, equals, or 2x plus 3y equals 6. Okay. And then you're going to use your cover-up method to graph it. So cover up the first one, and I'm going to write it over here. So we have our y-intercept and we have our x-intercept. And also those of you in Zoom, you can just recreate this on your paper too if you want. Okay, all right, what'd you get for your y-intercept? 2, perfect. And what'd you get for your x-intercept? 3, perfect. Okay, so cover up the first one, 3y equals 6. 6 divided by 3 is 2. Cover up the y term, and you get 6 divided by 2 is 3. Plot your points. So on the y, and you can just kind of fill it in, just create it. There's 2. And then 3, 1, 2, 3. And there is your line. Connect the dots. Okay. And we'll get back to the table, we'll get back to the parallel, perpendicular, and we'll get back to the slope in a minute. Okay? All right, so far so good. That really is the cover-up method. That's it. All right, now we're going to go to the slope-intercept method. So with the slope-intercept method, let me get rid of all my writings here. With the slope-intercept method, all that means is we're graphing a line using a different technique. That's all it is. Graphing a line using a different technique. You will get to the point where you get to choose which technique you want to use, but you have to know how to do both. You have to know how to do both techniques. So the slope-intercept method will always be set up in this setting, y equals mx plus b. We talked about that a little bit last week, or maybe on Tuesday. The m represents the slope. Okay, and the b represents the y-intercept. Okay, so because it's y equals, when you get an equation that looks like this, the 3x plus 5y equals 10, if I ask you to write it in slope-intercept form, you have to solve for y. Okay, so the idea is I'll do it live over here. Sometimes when it's already written out, it throws me. I have to actually do it. Okay, so if I'm solving for y, I'm going to peel everything off. So I subtract 3x, and I get 5y equals 10 minus 3x. So this is that two-step equation. So again, we're trying to get rid of everything around the y. So I end up with y equals, and then I simplify. 10 divided by 5 is 2. 3 divided by 5 is 3/5 x. So remember the x, the value next to the x is your slope. The y-intercept is the constant, so I can rearrange it. Oops, 5, 3. Plus 2. All right, so because this is, oh my gosh, 3. Come on. 3/5 x. So because this value is next to my x, that's my slope. And then the y-intercept is +2, or the 0.02. Okay. So again, being able to identify where the slope is and where the y-intercept is will really help. Now, we've said slope a bunch. What does slope actually mean? So a great example of this is, and you guys, if you drive down to San Antonio, as you're going towards San Antonio, you're dropping right there by the rest stop. There's a sign that says, I think it says 7% grade or slope, something like that. That's what slope is. So what it means is, for every, if it's a 7% slope, what that means is for every 7 feet run, rise, it's 100 feet run, because slope right here is the rise over the run. That's what slope is, rise over run. So because it's a decline, for every 7 feet I go down, I go out 100 feet. Okay, now who cares? Who cares about that 7% decline? Who would care? The truckers do. Yeah, because that puts a lot of pressure on their brakes, so they have to gear down so they're not wearing their brakes out. So the amount of decline and incline really matters. Down in where I used to live, there was trying to think if I've ever seen one. I don't think there's a hill big enough in Texas that has that has this, but they have a runaway ramp. So if you're going down the hill and you run out of brakes, there's a ramp that's all real thick gravel that the trucks will go off on the ramp and get slowed down, because otherwise they're not going to stop. So good for them. Okay, so slope is rise over run. So when you look at the slope right here of this equation that we solved for, here's what this means. The easiest way to do slope is you rise 3. So you rise, always rise, and you run 5 to the negative side. Okay, so if I were to graph this, let me move this over. If I were to graph this, I have, there was a, oops, get it on the line, there we go. Okay, so there was a y-intercept, right? So the b was 2, the slope was -3/5. Okay, so I'm going to put my point at 2. That's my y-intercept. And then I'm going to rise 3. So 1, 2, I'm going to extend this out, 3. And then I run to the negative side 5. Didn't mean to put a point there. So I rise 3, 1, 2, 3, and I run to the negative side 5 out here. So my line is going to look something like that. Now, how do I know that I'm running in the right direction? Well, if your slope is negative, if you have a negative slope, the line goes downhill, reading left to right. So in other words, if I'm walking along and I hit this line and I go downhill, that's a negative slope. And it's such an easy way to check, because you can always graph your line and always look to see, okay, I have a negative slope. That means it has to go downhill. If I have a positive slope, so let's say my y-intercept is -1 and my slope is 1/2, it would look like this. Here's my y-intercept. From here, I'm going to go rise 1, and then I run to the positive 2 steps. Rise 1, run 2. And because it's positive, I'm running to the positive side. And this is a positive slope. So how do you know it's positive? If I'm walking along and I hit it and I go uphill, that is a positive slope. Okay, so it's a real easy check to figure out, did I graph it correctly, positive or negative? Okay. All right. Oh, okay. So where the slope comes from, it's the change in y over the change in x. Sometimes you'll see it like this, change in y, or sorry, it's a y, not an x, change in x. So if you remember how to remember what comes on top and what goes on bottom, is the rise is your vertical line. That's your x-axis, right? It goes up and down. The run is your what did I just say? The rise is your y-axis. Did I say it wrong? Okay, sorry. I saw the look on your face. Oh, did I say that? The rise is your y-axis. The run is your x-axis. Okay? All right. So here is our slope formula. So this you will need to have in your notes for sure. So the slope formula is the difference in y's divided by the difference in x. So if you remember our very first week, we talked about ratios, comparing. That's all you're doing. You're comparing how far you're running up or rising and how far you're running. It's just a ratio, okay? So when you look at a line, you can find the slope just by looking at the line. First notice, okay, my line's going downhill, so I'm going to have a negative slope. That should always be your first notice. Then you pick 2 points on your graph. Pick 2 points. You create a right triangle between those 2 points. So I could have done a right triangle up here too. So it doesn't matter top or bottom. You count how far down you went or up and how far over. So I went down 3 and over 6. So I went 3 over 6, which is the same as negative 1/2. Or if you do it the other way, I go up 3 and over 6. So that's why I notice what my line is doing first, because then I don't have to worry about the down, up, right, left. I just count how many spaces up or down, how many spaces over. Write in those numbers and then reduce where I need to. Okay. Now, the other idea is I can pick a right triangle anywhere. It didn't have to be this big. So over here is the exact same line. I can pick this point and this point. Well, I went down 1 and over 2, down 1 over 2, down 1 over 2. So either way, I'm going to get negative 1/2. So again, don't worry about the up or down, right or left. Just count how many steps the rise, how many steps the run, put it as a ratio, and then look at your line. If your line is negative, it's going to go downhill. If it's positive, it's going to go uphill. Okay. All right. We'll get to the, oh, okay. We'll just do it now. So parallel. All right. Well, we're going to go with it. Okay. So parallel lines. Give me an example in real life. Lines on the road. What else? What would be a disaster if we didn't have parallel lines? Something that would wreck terribly if we didn't have parallel lines. Okay, so I mean they're probably not exactly perfect train tracks, right? The minute train tracks are not parallel, the train comes off the track and we have a disaster. So they have to be parallel. So parallel lines are just 2 lines that have the exact same slope. So write that, big letters, exact same slope. If the slope is not the same, you'd end up with, say, this one, and it could be almost parallel, but you can see how it would cross each other. So that is not parallel lines. So parallel lines have to have the exact same slope. Okay, now what about perpendicular? What does that mean? If you think of something that has to be perpendicular in your life, you're sitting in the room right now. If these walls weren't perpendicular, have you ever been to one of those weird, like mystery buildings? Yes, the lines touch. That's right. Nathan, do you know what let's see, what the angle is? Because I could have two lines that touch and those touch, but that's not perpendicular. What would make it perpendicular? Okay, perpendicular lines, guys are all very quiet, are at a what's called a 90-degree angle. Perfect. Good job, Nathan. Yes, 90 degrees. That means that it's exactly square, right? So that's why they put this little square sign in here, because it's saying that's exactly square. You have a horizontal line and a vertical line going straight up from it. That's a perpendicular. Now, when you look at perpendicular lines, their slope is what's called a negative reciprocal. Okay, so what does that mean? Negative reciprocal. Reciprocal means flip it over, right? It's the inverse or flipped over. And negative means opposite. Okay, so that means we have the opposite sign and the value is flipped over. So in other words, if I had a slope of 3/5, my perpendicular line, what would its slope be? Flip it over and change the sign. -5/3. Perfect. Okay. So it's this is going to ask you to in your homework, right? You have to find the slope, and then you'll have a parallel and a perpendicular line to that slope. Okay. All right. So here we go. We want to write this in slope-intercept form, and then we're going to identify the slope and the y-intercept for each line. Okay. So this really is what we did on Tuesday. So we have 2y equals 3x plus 8. You guys have all the tools that you need. You know how to solve an equation, okay, for a certain variable. So you just trust the process. I want y by itself, so I'm going to divide both sides by 2. And remember, you're dividing everything by 2. Because if you do something to one, you got to do it to everything to keep it balanced. So 3/2 x. And notice I'm not changing my slope into decimals or mixed number. Leave it top heavy, because then you have your rise and your run. You don't have to guess what the rise and the run is. And then 8 divided by 2 is 4. So on this one, the slope is 3/2. The y-intercept is at 0.4. And those are the two things that you need to graph, to be able to graph a line. You need the y-intercept and you need a slope. Y-intercept and a slope. All right, try number 2. Oh my gosh. Thank you. Wow. Tricks. You know, I did this for 2 years and no one ever told me. I never figured it out. I don't even know if I mean, I accidentally hit it, but that's funny. Thank you. Yeah, yeah. It's actually been more than that because I've been doing this forever. All right, here we go. So y equals, what is your slope? Right here. What's 3 divided by -3? -1, good. So -x, and then minus 9 divided by -3 is +3. And so your y-intercept is at 0, 3. Okay, now with the slope, remember we're always thinking rise over run. When we see a fraction, that's easy. Rise 3, run 2 to the positive side. What about -1? How are you going to do that? What's your rise? What's your run? What would be another way to write -1? Now, see, I'm clicking it, and oh, there it is. Oh, see, I've always, okay, I got it. I know, it's going to take me a minute. Because what's the other one? I'm learning something new on my pen, this thing. The other one, it was, what is that? So instead of this, oh my gosh. Okay, technology, you young whippersnappers. Okay, -1, your rise is 1, your run is 1, but you are going to the negative side. Rise and then run. Now, well, once we get to graphing, I'll show you. You can go down, but then you have to decide, are you going to go right or left? All right, here we go. Let's jump down to number 7. Okay, Zoom people, are you still with me? Any questions? But give me a thumbs up if you're good to go. If you're like, you're following it, you're understanding it. Good, Nathan. Good, Jamie. Daniel, thank you. Lyneth. Sophia. Okay, good. All right. All right, so see a fraction, eliminate the fraction. It just makes your life easier. Otherwise, you're going to have to move this 1/3 x over and then divide fractions by 2. Don't want to do that. I mean, you could. It's not the end of the world, but I'm trying to make your life as easy as possible. So we're multiplying everything through by 3. Is there a trick to changing colors fast?
No.
Oh, okay. All right, so 3 goes into 3 one time. -2 times 3, and 3 goes into 3 one time. So we end up with x minus 6y equals 2. Now we can solve very easily. Say that again. Yeah, and then it pulls down. Yeah. Okay, so x minus 6y equals 2. So again, now we're doing slope intercept, because if you look at this, remember this is in standard form. If you look at that, you can't really see the slope. I can show you, I'll show you a trick to find the slope easily. But right now, there's no slope that just jumps out at you. So you're going to solve for y. Divide both sides by -6. And you get y equals 2 divided by -6 is a -1/3. All right, is this going to throw any of you? The negative x over -6? How would you rewrite that? What number is in front of that x? A 1. So you're going to write it as plus 1/6 times x. So then to put it in slope-intercept form, it's 1/6 x minus 1/3. Okay, so there's always, if there's no number there, there actually is a number there. It's an invisible 1. So you can rewrite this, any variable over a denominator, just write it as 1 over whatever that denominator is. Okay, so on number 7, what's your slope? Which one's the slope? 1/6. And my y-intercept? -1/3. Perfect. Good, good, good. Okay. All right. So on number 9 and 10, it's asking you to write an equation of the line for slope with a slope of 3/4. So just remember, an equation of a line is always in the form y equals mx plus b, or ax plus by equals c. You can write it either way. This is actually the easier version to write an equation of a line, the y equals mx plus b, because the m is sitting there, the b is sitting there. So if you're writing an equation of a line and the slope is 3/4, you're going to go y equals 3/4, there's your slope, x, and it does not matter what your b is. You can do nothing, that would make it a b at 0. You can do 1, 2, 3, -1, doesn't matter. Just use that slope next to the x. Okay. And then 10, you're writing an equation of the line with y, where the y-intercept is -50. So again, doesn't matter what your slope is, as long as I have -50 as my y-intercept, you're good to go. Okay. So that's all the basics. There's all your basics. Now let's get to the graphing. This is my favorite part. All right. Because we want slope-intercept format, that means you have to solve for y. Okay. So you have to, when, like on the test, if it asks you for slope-intercept, you have to know, okay, slope-intercept means I have to solve for y. If it asks you to do the intercept method or cover-up method, then you'll use that method to graph. Okay, so you have to be aware of which method you're using. And then if it doesn't say use one method or the other, then you get to choose which one you want to use. All right, so here we go. First things first, you want to solve for y. All right, I'm gonna do something, because this is a very common error. Love that part. All right, common error. What did I just do? And why can't I do that? Because they're unlike terms. Good. So be aware of that. You can't add unlike terms. So we have 15 minus 2x. They're two completely different things. And then I'm going to divide both sides by 3. So I get y equals 15 divided by 3 is 5. -2/3 is -2/3 x. And then I'm going to rearrange it. Hang on to that negative though. So identifying the slope and the y-intercept is going to make your life so much easier. The y-intercept is at 0 and 5. So I'm going to come over here and I'm going to put a point on my graph on my y-intercept. My slope is negative 2/3. So I'm going from that point, not from the origin, but from the y-intercept. I'm going to rise to, and then I'm going to run to the negative side 3 and put my second point. So these little dots, those are just me counting. You only have 2 points on your graph. You have a point at the y-intercept, and you have a point once you get to your slope. So rise to, and I'm running to the negative side. And then there is your line. And it's straight. Because remember, slope-intercept form is the y equals mx plus b. So it's just to make sure that you know that the value next to the x is your slope, right here. And the constant, the b, is your y-intercept. So this step right here, from here to here, it's not mandatory. It's just if you recognize that, okay, this is y equals mx plus b, this is my m, and this is my b. So you want it in that y equals mx plus b format. Okay. All right, any questions? So first step, solve for y. Next, identify your y-intercept and plot it. And then from that point, identify your slope and rise and then run. Okay? All right, next one. Here we go. Number 12. Go ahead and try it. Oh.
So you have to put green,
Uh-huh.
go to far left, next to the eraser.
Oh, over here.
Go down.
Those are, so, but this one's green. So if I want to, oh, okay. So I can change them. See, I didn't realize these were, I thought they were of different thicknesses.
You can do the, so when you do the menu.
Oops. Trust me, that's what that pops up.
So when you go to the thickness is on the side.
So then you can just go through and do each one.
Pressure. You push down hard on it. Do a bigger thickness.
But not this.
No, that is like chop. Like.
Okay, but I'm doing. Nope, it's the same. Yeah.
Okay.
No, and so all of these are the same pencil, just because like this one is thicker, that's thinner. This one's thicker.
Yeah. So you just customize those. Okay,
and then the thickness.
Just go to menus.
How come you didn't do this for us?
I did.
Did you share that?
Yeah.
When?
Yeah.
I'm sorry. You know what? I know, right? It's the little things. Oh, okay. So then you have all your colors. I like it. Okay. All right. So we got it.
Delete some if you don't need it.
Okay. So how do you delete them?
Pencil next to the sharp or the highlighter.
Yeah.
You have to use your mouse for that. Right click on it.
Oh, okay.
Delete.
Ah, and it's gone. Look at there.
Use the highlight.
Yes, I do use
And just pick whatever color you want.
that. Look at you. Thank you. That is so much easier.
And if you have a terrible drawer.
Yeah.
that needs-
Yes, I have used that one.
Then I do survey, like, here's my set. Then it fixes.
I've tried the math to text where it changes it, or ink to text. It's picky. I don't like it. Yeah. Yes. Yes. Okay. Nice. All right. Learning something new every day. All right. So here we go. We're going to add 5x to both sides. Get y by itself. Okay. So Yuritsa, if you are fine with this, which one is your y-intercept? The one. Good. So 0, 1, and the slope is, oh, it's only 5. So what's your rise? What's your run? 5 over what? Perfect. 5 over 1. Okay. So once you identify that, then you're good to go. Here's 0, 1. From there, I'm going to rise 5, 1, 2, 3, 4, 5, and run 1 to the positive side. There it is. There is my line. Yeah, I've tried to do the line shape. Yeah, exactly. It's a mess. Yeah. So I'll just meet you there.
Yeah.
If you need to get back, we can do it another time too. Okay. Right.
I was like, well, I'll leave my bag here.
Okay.
Yeah.
Don't forget your glasses.
I'll leave that.
Okay, sounds good. Thanks, Robert. Hope you learned
I
something.
did it.
I did. I learned something. All right. Okay, so all good? Any questions? Not too bad? Is it going to be okay where you have to do both? Like you're able to separate the two? Because like number 12, when I look at that, I go, oh, I can do, because it's in standard form, I can do the cover-up method. Whereas, where's one? See one. If there's one that's already set up as y equals, then you can do the slope-intercept method. Okay. All right. Let's try number 13. So fractions, I always like to give you at least one fraction so that you get practice eliminating that fraction. Okay, so I went ahead and showed it. We're eliminating it by multiplying through by 8. So 8 goes into 8 once, 4 goes into 8 twice, and 2 goes into 8 4 times. And then I multiply. 1 times 5 is 5x. 2 times 1 is negative 2y. And 4 times 1 is 4. So everyone good there? Whether you multiplied through and then reduced or reduced and multiplied, that's what you should have got. All right, now solve for y. Divide both sides by, or all by -2. So we get y equals 4 divided by -2 is -2, and then plus 5/2 x. What did I do? X, sorry, should be an x. All right, so again, if you need to, you can rearrange it. You don't have to. It's just I want to make sure that you have it in the right position. So your y-intercept is 0 at -2, and the slope is a positive 5/2. So here we go. Put a point at -2. From there, we're going to rise 5. 1, 2, 3, 4, 5, and run 2. And then always double check, since you have a positive slope, your line is going uphill. So that makes it a positive slope. All right, now one thing I wanted to show you real quick, because this has come into play. So let's say, let me go in here. Let's say I had an equation, y equals -5/2x plus 4. Okay, and let's say that my graph only goes to this big, right? 1, 2, 3, 4, 5. That's as far, it's as high as it goes. So the way that I'm teaching you, I said, okay, our y-intercept is at 0, 4, and my slope is -5/2, right? Okay, so if you ever come to this problem where, okay, I'm going to put a point at 0, 4, so there's my y-intercept, and Mrs. Manchester keeps telling me to always rise. Well, you can see I'm running out of room. Okay, so you may have to rise down, but just remember, if I'm going down, I'm going in the negative direction. And that's why I always like to just rise and then run positive or negative. Because if I go down 1, 2, 3, 4, 5, then I have to figure out, am I going to go to the right or to the left in order to have a negative slope? So in other words, if I go to the negative side, you can see I end up with a positive slope. I have a negative slope. So that's why you just have to be aware, if you have to go down, that's going in the negative, and so I'm going to go to the positive side to make it a negative over a positive, and then I have a negative slope. Okay, so always just double check your slope to make sure that yes, indeed, that is a negative slope. Okay, so going down is okay. Just be aware is you got to decide, am I going to go right or left to make it negative or positive? Okay. All right, let's see, what else can we do? Okay, we're good there. Okay, so now we're going to jump into something that we are plotting points, right? So we're just going to plot points, and then we're going to draw a line, and then we have to find the slope. Okay, all right, so here we go. First, so this is number 16 on page 85. Yeah, 85. All right, so here we go. 6 and -2. So I go over 6 and down 2, that's 1 point. And then 8 and -3. So over 8, down 3. And then draw a line. So again, any 2 points create a line. Okay. So to find the slope, all you have to do is create a right triangle. And I just do it between the 2 points because I know the points are accurate. I rise 1, I run 2, and is it a positive or negative slope? Negative, it's going downhill. So there's your slope. Okay, so you should always be able to find your slope when you have a line sitting in front of you. Okay. All right, so now you don't have a line sitting in front of you. Now you have to find the slope. So now we're on page 86. Okay, so this goes back to our slope formula. So the slope formula is the difference in y's, so y2 minus y1, over the difference in x's. The difference in y over the difference in x. So we're going to use these same 2 points, and we know what the slope should be. The slope should be -1/2, right? So let's try it. The y, so remember, x is the first value, y is the second, x is the first, y is the second. Okay, so this is my first set of ordered pair. That's my second set of ordered pairs. So on my slope formula, I'm going to do y2 minus y1 over x2 minus x1. So really watch your signs. This minus sign is not this minus sign, 2 different ones. So I end up with -3 plus 2 over 8 minus 6. So -3 plus 2 is -1. 8 minus 6 is 2. So y2 minus y1, x2 minus x. And there's your slope. Okay, now why this works. If you look at this graph, if this point right here is 6, -2, and this point right here is 8, -3, when you find the slope between those two, you're literally finding the difference in the y values and the difference in the x values. The difference between -2 and -3 is 1 step. The difference between 6 and 8 is 2 steps. Okay, so that's where that formula comes from. It's just the change in x over the change in y. Okay, we'll get to a fraction 1 in a minute. Let's try 21 and 22. I don't want to stress you out too much. So slope formula. We have x and y, x and y. This is my first, that's my second. And it does not matter which order. I could have 5, -3 be my second and 1, -3 be my my first. It doesn't matter which order, just be consistent. So we have -3. Oops, where that came from. Minus a -3 over 1 minus 5. So I have -3 plus 3 over -4. So what does this become? 0. Yeah, 0 over -4 is just 0. All right, so your y, did you notice your y value is the same number? They're both -3. Okay, so what this tells me is this is a horizontal line. This would be the equation y equals -3. Right? So if you have a horizontal line, and you're looking at the slope, does 0 make sense? I have 0 rise, -4 run. So if I have zero rise, that means it's not going up or down. It's staying flat. Okay, so horizontal line, your slope will always be a zero because it has zero rise. It never goes up or down. Okay, so horizontal line, slope equals 0. Right, so 22, if you notice, the x's are the same. So if we set up our slope formula, -7 minus 4 and 1 minus 1, we get -11 over 0. And anything over 0 is what? You know what that term is? Undefined. Yep. It's undefined. Well, this is my x equals 1. So this is my vertical line. So if you have a vertical line, you have all the rise in the world, but no run. It doesn't go right or left. So vertical line slope is always undefined because it has no run. Okay. All right. So I want to go back to this. Oh, I did have to erase it. Okay. So now I want you to flip your map over, and it should say SlopeIntercept method. So this, we're going to do the SlopeIntercept. It's on the other side of the one we already did. So the SlopeIntercept method. So your equation is y equals -1/3 x minus 3. And then go ahead and graph it. You can find this in your in the Canvas class. It's under the resources for this section. I think I posted it yesterday, but if I didn't, I will do it as soon as I'm done. Or you can just draw it. It's just 4 sections with a circle in the middle. Of course. All right. So your slopes over here in the bottom left side, your slope is -1/3. And I'm going to go ahead and add in my y-intercept is at 0, -3. So I'm going to put a point at -3. I'm going to rise 1 and run 3 to the negative side. So my slope is good. It's going downhill. Okay, so now I can answer these questions: parallel line, perpendicular line. So what is the slope, or will give me an equation of a parallel line? So what do we know about the slope of a parallel line? It's always what? No, parallel line. Remember that they have the same steepness. The same, good. So parallel line, slope is the same. So if I wanted you to write an equation of a parallel line, it would be -1/3 x and then plus whatever value you want. Or you don't have to have a value. You can leave it as just -1/3 x, and the value would be, the y-intercept would be 0. All right, what about perpendicular lines? What do we know about the slope? So negative reciprocal. And reciprocal just means flip over. So my equation of a line, I flip it over and switch the sign. So you can add in flip and switch. That's perpendicular line, always a flip and switch. So I flip it over, it becomes 3/1, which is just 3. It was negative, now it's positive. And I can leave it at that, y equals 3x. That works. The y-intercept is 0, and then my slope is 3. Okay. And then the table is just a way to plot points. If you forget what the process is, the y-intercept, and then rise and run, you can just plug in values. So if x is 0, I'd go 1/3 times 0 minus 3. So it equals -3. So y equals -3. If x is 1, it would be -1/3 times 1 minus 3. So -1/3 minus 3. So it would be a -3 1/3. And then I always use 0, 1, and -1. You can use any values you want for x. It does not matter. So if I plug in -1, I get -1/3 times -1 minus 3. So this becomes a -2 2/3. And on your graph, all of those should work. 0, -3, there's that. 1, -3 1/3, and then -1, 2 2/3. So I'm good. It all falls right on the graph. So when you graph it, yep. Yeah, I always rise. So from this y-intercept, I rise 1, and then 1, 2, 3 over. Yep. Because that's that idea, you always rise and then you run to the side of the sign. So if it's a -1/3, I run to the negative side. If it's a +1/3, I run to the positive side. And that way you don't have to guess. You don't have to go, okay, which way do I need to go to make it a negative line?
Rise and rise, rise, go with it, go up, and then rise, continue on the side, positive.
Yep. 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 That's exactly it. Yeah. Okay. All right. Any other questions on this one? So this is what you can use for your test next week. So kind of, whatever notes you need to put on there to make it easier, like on the graphing, if you want to do, to graph, plot y-intercept, and then rise and run, something like that. Whatever type of notes you need to kind of give you a little, hint. If you're nervous about the test, or if you forget something, you can look at your notes and jump right back in. Okay, and make sure you can read them. All right. So the other side, what did we do? Oh, okay. The other side, let's go back and fix this one. So the other side was our intercept method. We'll finish it. So this is our cover up, intersect method, which I call cover up. And we had a point at 0, 2, and a point at 3, 0. Those are our intercepts. So this is our y-intercept. That's our x-intercept. So 0, 2, 1, 2, 3. Here's our line. Okay, so to find your slope, super easy. Remember, slope is the rise which is the y, over the run, which is the x, right? So remember the technique, let me get my yellow pen, the technique of plot 2 points, the points are right here. So we have, here's our right triangle, rise 2, run 3. So our slope, the y over the x, do you see it? The y over the x, and then look at your line. It's going downhill. So that makes it a negative slope. So the y-intercept over the x-intercept. Y-intercept over the x-intercept. Or plot your graph and then just count. Rise and run. All right, parallel line. Equation of a parallel line. Remember, the slope is the same. So our slope is negative 2/3, so it's going to be negative 2/3 x, and then whatever b you want. And then perpendicular, do the old flip and switch. So turn it over, switch the sign. So it was negative, now it's positive. Now with the table is a little bit more involved when it's set up this way because there's no one variable. So you can do it a couple different ways. You can put just, 0 in for x, which is exactly what the cover up is, right? If I put 0 in for x, I end up with 3y equals 6. So y is going to equal 2. If I put in 0 for y, which is exactly what the cover up method does, I end up with 2x equals 6. So x equals 3. And that's really all you need to do when it's set up in the standard form like that. Just look for the intercepts. So it's just a repeat of the cover up. Okay. So again, whatever notes you need, you can add to that and you can use that for your test. Okay. All right, last thing. So oh, I know what I wanted to do. I wanted to do 2 problems finding the slope using slope formula with fractions because I know how much you guys love fractions. Now, I'm always telling you to eliminate the fraction, right? Just eliminate it and then you don't have to worry about it. That only works when there's a variable in there. Okay, so when you're looking for the slope of a point where you have fractions, you just have to go back to how do you do fractions? So you're subtracting, adding, you need a common denominator, and then you're dividing, which means you're going to flip and multiply. So let's try it. So 18. So remember, x and y, x and y. So negative 7, 6 minus 5, 6. Oh, this is set up so nice. You don't have to get a common denominator. It's already there. And then 5/3 minus 2/3. And so when I say be consistent, notice I used this one first on the top. So I'm going to use the x value on top, on bottom first. So just be consistent. In other words, don't mix them up. If you use whichever set you use first, make sure it's used first on both the top and the bottom. All right, so we got negative 7 and a negative 5, so we get negative 12 over 6. So this is just the top. So negative 12 over 6 is negative 2. And then on the bottom, we have 5/3 minus 2/3, which is 3/3. Look how nice this is. Whoever wrote this was very kind to you. So 3 over 3 is 1. So your slope is negative 2. So you rise 2, run to the negative side 1. Okay, and then number 19, last one. I'll let you get started on it. So this, now you have to find a common denominator. Okay, so I did a common denominator of 35. Does that sound reasonable? So on the top, they're both negative, yeah. So on the top, I get a negative 48 over 35. So I'll leave that there. And then on the bottom, I have 1/2 minus, and all I'm doing is I'm changing that 1 into a common denominator fraction. So 1 is the same as 2 over 2.
Yeah, I would be, I didn't like to.
Oh, did you guys do, oh, darn it. I was looking at 20. Sorry. What was 19? Oh, did you guys do 19? Okay. All right. Let me finish this and then we'll do 19. So keep going on 19. This is 20. Gosh. I was so excited that there was only one more. It's so funny. I used to get so nervous when I'd get observed. Now it's like, meh. I've been doing it way too long. All right, what'd you change the 3 to? Because you do need a common denominator on number 19. What is it? 24, there it is. Okay, so here is a really, really, really cool trick. I know I have to get a common denominator, right? I know it has to be 8. So all I'm going to do is multiply. What's 3 times 8? 24. So 24 over 8 gives me 3. So it's just very, very fast. If you have a whole number, just multiply it by the common denominator. And then you don't even have to think about it. All right, so we have 21/8 divided by -7. So how are we gonna do that? That's what it looks like. That's what that division sign, that's what that fraction sign is. So what are we gonna do? Yep. Say, what did you say? Keep, change, flip. I always forget that saying. You keep the first one, change the second one, or change the division sign to multiplication, and flip the third one, keeping the sign. Don't forget the negative sign. So keep the first, change the sign, flip the second one. And now I can cross cancel. So it becomes a -3/8. There's your slope. Okay. All right, any questions? So you have, so key points. You have your slope formula, know how to use that. You have your intercept / cover up method to graph. You have your slope intercept to graph. Yes, I can, Nathan. There's number 20. You circle the answer for you. And there's the answer to 20. So put that, if you haven't done 20 yet, put that next to it so that you can work towards it. You're welcome. Okay. All right. So here's what this next week is going to look like. So do you need more time for your homework? No. Okay. Yeah. Okay. All right. Yeah, I have it set for the 20th because we literally just went over it today. I'm going to move that. So this will be due Tuesday, September 24th. Okay, so 7, 8, and 9 will be due Tuesday, the 24th. And then don't forget, it's on the other page. Quiz number 5 is due the 25th. Okay, so we have the 24th, so I'm going to change that today. 7, 8, 9 are due the 24th, and then the quiz 25th, and then Tuesday, the 24th, we have a review. Thursday, we have our first test. Okay? All right, have a great weekend, you guys. Yeah, go ahead, you hear it?
Hello, can you hear me? Well,
Yes.
okay. I didn't get the last part. When's the test?
So the test is next Thursday, the 26th, so in 1 week.
Okay,
I
thank you.
know, it's here already.
Yes.
So on Tuesday, we'll review, and the test will be over homeworks 1 through 9.
Okay. Okay, thank you very much. Have a good weekend.
Okay, you too. Oh, what time do you have to go?
7 p.m.
Tonight. Okay, so you can still go home and rest.
But like